Hello and welcome. In this video, I'm going to introduce few improvements that we have incorporated into the Blendshape-based pipeline. We will briefly go over the different features and then continue with a more practical step-by-step example. First, we have added an eye blink augmentation to ensure that the Blendshape animation fully captures the eye blinks generated by Audio2Face. The Blendshape solver estimates the best weights for the given Blendshape model in order to reproduce the facial expression generated by Audio2Face. In previous versions, the Blendshape solver was sometimes unable to capture the fully closed-eyed expression. Since blinks occurs as a rapid closing motion of the eyelids, factors such as the frame rate or the timing of the blink would present a challenge to the solver. Even it can be challenging to realize where it was fully closed with just the naked eye.
Good morning, Professor Austin. How are you doing?
Let's go ahead and stop the animation at the blink.
Good morning, Professor Austin.
In this new version, the blinks are captured correctly. Behind the scenes, Audio2Face issues a blink signal that is directly computed when estimating the expression weights. If you are setting the pipeline manually, you would need to connect the new blink weight output and input of the core and solve nodes. The blink augmentation setting can be accessed by selecting the Blendshape solver node, either through the Audio2Face data conversion tab on the OmniGraph or directly on the stage view. At the bottom of the properties, you will see the new blink augmentation settings. When using the Declare or Mark Blendshape templates, the blink augmentation is set automatically. If you are using a custom Blendshape model, you can easily set it up by selecting the shapes on the Blendshape list and adding them to the blink pose field. With the test button, you can verify the right way to obtain the fully closed expression. When satisfied, simply exit the testing mode.
Good morning, Professor Austin. How are you doing?
We also incorporated few advanced export options to adapt to different production pipelines. The new options can be found on the Audio2Face Data Conversion tab on the Blendshape and Join Conversion section, and then under the folding Advanced Export Options menu. The first three options are related to exporting joint-based transformations for the eyes and jaw. By default, without specifying these options, the transformations for the eyes and jaw will be exported based on the Audio2Face own transformation hierarchy. More specifically, in Audio2Face, the eye transforms are centered on the eyeball with the Z direction pointing forward and the Y direction pointing upwards. The jaw transformation is even more special as it's placed on the world's origin, enduring both rotation and translation during an animation. This setup might not be the most convenient for custom characters, especially if you plan to continue editing in another TCC. So if your character has a skeleton with joints for the eyes and jaw, you can specify them in their respective fields, and the transformation of the eyes and jaw will be converted to the local space of the specified joints. In order to visualize the skeletons in Audio2Face, please install and enable the skeleton visualization extension in the extensions windows, and also enable the skeletons on the viewport as well. Finally, the last option enables exporting the tune weights rather than the raw output of the Blendshape solver. The tuning is done with the float array tuner node. This is an utility node that allows to modify individually the estimated weights by multiplying a gain and adding an offset. This is useful in several practical cases in which we want to use the estimated Blendshape weights to puppeteer another character. The float array tuner provides a controllable mapping between the Audio2Face character and that of the character. We can modify the mapping on the Properties tab of the tuner node. By tuning this mapping, we can ensure, for example, that both characters generate semantically similar expressions or with a similar degree of intensity. Here in this example, I'm going through different expressions and enhancing some expressions such as the funnel or actually softening the jaw opening.
春日起眉早，采桑惊啼鸟。风过扑鼻香，花开落，知多少。
Practical situations where the tuner node is useful include streaming blend shapes through the Stream Live Link node, for example to a metahuman character. In this case, if the receiving character is different, the tuner can be edited to obtain a good mapping between the characters. Similarly, the tuner node can help mapping different characters within the Audio2Face app as well. Let's continue with a step-by-step example in which we will set up this character. This character, it's basically has the full body, but the head and the eyes and jaw, it's already separated in its own kind of meshes, so it's ready to be set up in Audio2Face. Another thing that we can notice is it has its own skeleton. If we want to visualize it, make sure that you have the skeleton visualization extension installed and enabled. And to visualize them, go here in the viewport menu and show the skeletons. And here we have it. So as you can see, we have joints for the eyes as well as for the jaw. So in this example, what we're going to do is set up the head to be driven by Audio2Face. This character also has blend shapes, so we're going to use this blend shape model to solve the animation so that we can have blend shape animation. And then we will export it so that maybe we can use this animation in another DCC for this character. And we will use these new options for the export to specify that we want to use the joints for the eyes and jaw rather than the original Audio2Face hierarchy. So let's get started with this. First, maybe we can hide the skeleton for a while. And let's get started with the character transfer. Again, since the goal is to just generate blend shape animation, we don't need to do the whole full setup. We will just pick the things that we needed. So first, we're going to select the head. And you can see the orientation is also already matching. Then we're going to go to the jaw group and select the teeth and the tongue. And we will move to the eyes. Again, here we have other geometry, but since we just want to export the information rather than using the setup, we just need to pick only one. Same for the right eye. And then for the pivot, we have actually the right information here on the pivot X form, but in between the geometry, basically the parent of the geometry, it's basically set up here on the origin, which is not good. So rather than that, we will just compute the pivot directly from the eye meshes itself. And here in the static, basically we'll not use. These are just for kind of cosmetic purpose. So now let's set up the character. And we can hide the original character for the time being. And then the next step is to generate the correspondence for the character and the template. For this, we can use the new interactive detection, which will guide and already generate some kind of correspondence information for the templates. Since it's a cartoon character, we will probably need to edit manually, but still it provides the full correspondence already for the template character. So the way to get started, since it's a cartoon character, we'll use the interactive detection. The fully automatic works better for human characters. First, just click on the interactive detection, and it will place 5 guide correspondences. As you can see, it did an alright job. So let's modify them. Here we have to pick basically the corner of the eyes, the tip of the nose, and then the corners of the mouth. As you can see here, the lighting is a bit annoying. It's creating a quite strong shadow, so we can use the camera light. It's basically like having a flashlight from behind the camera, so it always provides this kind of nice lit information. So this is quite helpful, especially for when working with correspondences. So these are just guidelines, and especially since it's a cartoon character, we will have to modify the result anyway, so it doesn't need to be super accurate. Once you are satisfied, we can click the interactive detection again, and then it will bring the full 27 correspondence set. It did all right job, but still need to modify a little bit. For example, like especially like this mouth area. So in here, we would continue the editing process, but I already did it behind the cameras. So let me just bring the final correspondences. Here is how I set them, especially attention here on the lip area. And I just added as well 3 more correspondences here on top of the ears to help the mapping, and 1 at the back of the head. So with that, we can continue with the mesh fitting. And we can see that somehow the shape is well reconstructed. So we can continue with the post wrap, then the jaw motion preparation, and then the tongue mesh fitting and the tongue wrap. At this point, we can also just hide the correspondences, and then basically our setup is finished. We only need to set up the Audio2Face pipeline and check that the animation is working correctly. The next step is to set up the Blendshape solver so that we can actually estimate the Blendshape weights for the animation and then proceed with the export. For that, we're going to use the original character head. Here, if you check, this character already has the Blendshapes of the AR kit, so the 52 Blendshapes. So we're going to use this head as the here in the Audio2Face data conversion, we're going to use this original head as the Blendshape mesh. So let's go ahead and set up the Blendshape solver pipeline. So first, we're going to select the transfer character. So here in this mesh, we will find the world transfer character, the head result. That's the one that contains the animation. If you are not sure, you can see that the original copy of her head has actually, it's hidden. The one that it's actually shown is the result. So always make sure to have the result here. And then for the Blendshape mesh, we're gonna use the original. So that's the inside the character, and the T of her head. So here, this one. And then we can set up the Blendshape solve pipeline. All right, so let's bring this head a bit up so that we can actually see whether this is working correctly. And then see that basically the solve was done correctly. All right, so now that we have the Blendshape solver setting, one thing that we can see is that actually in this case, the eyes are closing quite well. That's nice. And this is because the eye blink augmentation is already working perfectly. You can see that our transfer character, actually it doesn't close the eyes correctly because the eyes are too big and it's kind of a cartoon character. But when we actually solving the Blendshape, the eye blink augmentation is working correctly. If we wanted to, sometimes for these characters, we can adjust this. If we had actually different Blendshape that are not the AR kit, then we would have to modify this eye blinking manually. So we can go here in the lazy graph and find the Blendshape solver or actually more easily, we can just simply select the solver here. And then you can see that the blink poses are already detected. If we had a different model and the names didn't match, then we would just simply have to select them. So for example, if I remove the setup, you can see that now the eyes doesn't close. They just kind of follow what the transfer character is doing. But so we will select, to set up the blink augmentation, we will select the shapes that actually corresponds with the blink and then add them. And then we can test what is the right weight for this. So some characters can actually have different weights. So basically when testing, just make sure that the eyes are fully closed. If you want to go higher than 1, you can just double click and just set the value directly here, or you can drag, but this one, the dragging basically just goes up to 1. Once you are satisfied, we can just simply remove the test, and then while playing the animation, now you can see that the eye augmentation is working correctly. Perfect. So now the last remaining step is basically work on the exporting. So let's bring back this character in its original place, now that we know that it's working correctly. And we can also maybe just hide the original transfer character. And we will set up the export options. In this case, we can bring back our skeleton. And here, what we're gonna do is select the different eye joints. Before we do that, let me talk about the tune weights. So let's open the graph. And when you set up Blendshape conversion, by default, it takes some time to kind of find the layout. So let's find the Blendshape deformer. Here it should be, let's just find it directly here. Here it is. So you can see that the Blendshape solve receive the blink weight from the Audio2Face core, and then basically it outputs the Blendshape names and also the Blendshape weights, and this is sent to basically the stream live link. So if we wanted to control character with in MetaHuman or in another application, we would be able to do that. And then these same weights are used as the right prim to basically set up the animation on this original head, the geoferret head. So basically these weights, we can see the effect. Since we are not live streaming right now, we can delete the live stream. And to see the effect of the float tuner, what we can do is disconnect this array and then actually connect the float tuning array output directly into this right prim. So again, let me hide the skeleton for a second. So now what we are seeing here is the output of the float array tuner. If we want to modify the mapping, so by default, you can see that there is some values, and these values are kind of already prepared for driving MetaHumans. So if you wanted to just modify this, we can set all of them to 1 or 0, or basically choose what you want. So let's see, let's find an example. So for example, here we have open mouth, and I want to see whether I want this character to be more expressive. So we can make the mapping so that the a small opening here actually creates a much bigger opening there. So now every time this character opens the mouth, we have this kind of big mouth here. And maybe same for the funnel and the poker. I want to exaggerate the expressions. So that's how you can use the float array tuner. Now that we have this setup, basically here in the conversion and export, if we don't specify this tune array, basically we will just simply export the original weights. We can see the difference by actually changing the connection. So this was the original weights, and here is the tune ones. So basically in the conversion, we can choose whether we want the original ones or the tune ones. If you want the tune ones, basically you can select the float array tuner and just edit here at the tune weights. And we will do the same for the skeleton. So we have our skeleton here. Let's show it. So what we want is to use here the jaw joint. And you can see that the orientation is already different than the Audio2Face. So we can just add it. That will be the joint that we want to use. And then we have a joint for the left eye, and also a joint for the right eye. And with that, we are ready to export our animation. So you can choose whether you want a JSON file or a ASCII file, and then you can simply export the weights. First, I'm going to export the JSON. We have to select the solver. And yeah, let's just choose a different folder. So here I'm gonna say this is just the folder, and we're gonna call it ferret Blendshape animation. And let's export the weights. Check that's the right filing. Now that it's exported, we can check the animation. I'm gonna just import the JSON file into VS Code, and we can see that when expecting this file, we have the fax names. We also have the weight animation, and then we can see that now the joints and the rotations are specified for the joints that we set. So the rotations, there will be like 3 rotations per each frame corresponding to the joints that we have here. So the first rotation for the jaw, the second for the left eye, and the third for the right eye. And then we will also have the translations corresponding to the skeleton. So that's it. Now with this export information, you can bring it to any to your own DCC like Blender or Maya, and then use this animation any way you want. We hope that these features will prove useful. Please check our forum and Discord channel for doubts or any feedback. Thank you.